Hello, am I audible? Hello, Moshika,
Yes, sir.
I'm audible.
Yes, sir.
Okay, okay. So let's begin today's session. So my screens are visible to you.
Sir. Yes, sir.
Okay, perfect. Is it in full scale mode? Presentation mode? Hello,
Yes, sir.
are you able to visit? Are you able to view it in presentation mode? Sorry. Please respond so I can start the session. I hope it is visible in full scale mode. Okay. So let's begin today's session. I'm Karthik Jadhav, uh, fourth year PhD scholar in the Department of Water Resources Development and Management, IIT Roorkee. I'm also currently Prime Minister Research Fellow and at IIT Roorkee. So I'm the EMRF teaching assistant for this irrigation and drainage engineering course. So this course is basically run by Professor Damodar Rao Milapalli from IT Kharagpur, and these are my general background. So yes, as I told that currently I'm doing my PhD in water resources management in the Department of Water Resources Development and Management, IIT Roorkee, and I did my master in land and water resources engineering from Department of Land and Water Management Resource Engineering at IIT Kharagpur during 2029 to June 2021. And before that, I did my bachelor's in agricultural engineering from CIT Kodra, Anand Agricultural University. During in between, as I joined my PhD, I also worked as a junior research fellow in the Department of Science and Technology funded project on design of climate resilient agricultural waste management strategy. And also, I have many research training experiences in various NGOs like Verti Foundation as well as Sadhguru Foundation. So, if you have any query, so these are my contact information. You can write it me directly on this email ID. So I will try to return mail within 24 hours, and uh, don't forget to put subject irrigation and drainage, or you just mention IDE in the subject of email. And what I will do, whatever content I am going to cover throughout this 12-week NPTEL course, I will upload each and every session, recorded session, in my YouTube channel. So this is the QR code. You can directly scan it and uh, uh, get it this channel, or you can also do this by clicking this link. So directly click to this link and you will able to access all the recorded materials that I am going to cover. Apart from that, I will also upload all the lecture materials like this PPT, today's PPT. So don't worry about that. I will upload in this drive folder. You can easily access this. Okay. And before we begin, let's get short introduction of joint people. So get to know about that, and then we will move further for detailed course problem, question and answer, as well as a short summary of a particular session. So we'll start with Kaushika.
Okay.
Please introduce yourself briefly. So, like, we'll get to know each about get to know about each other, and also like why did you choose this course, and what are your learning motivation that you are expecting at the end of this course. Can you please briefly tell about this? Hello, hello.
Hello. Sir,
You are not audible. I can hear you.
my name Paushika, sir.
Okay,
My hobbies is agriculture farming, sir.
agricultural.
Farming, sir. The
Okay, so you are from you are doing BSc or BTech in agricultural
BTech,
background?
sir.
BTech in agricultural engineering.
BTech,
Okay,
yes,
from
sir.
where? From where?
And we,
Yes. Sorry.
sorry, sir. Network problem in this.
Okay, okay. No issue. No issue. Try to get it network stabilized. Okay.
Oh, thank you, sir.
Okay. 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 So anything else? Tanvi Satvara. Also the same problem. So let's begin today's session. So in this lecture, as already introduced by Professor Damodar sir, regarding what the courses or what are the topics that we are going to cover in this 12-week course. So this course is divided in two parts. So first 6 weeks are, or first 6 or 7 weeks are more focused on irrigation part, like what kind of irrigation technique we need to consider, what type of uh, design consideration we need to take care of, and what are the essential requirement to understand the irrigation and drainage engineering uh, subject, right? And then we'll focus on the groundwater and wells and pumps, so that is part of groundwater hydrology. And in between, we'll also focus on how to understand the problem related to salt in agricultural area, agricultural soil particularly, and how to remediate it, what kind of remediation technologies are available, and we'll also understand about various problems that might ask during your GAT, NET, JRF examination, particularly from this subject. So it is very wonderful part of this subject. So today's is 26th of July 2025. So at the these are the schedule that particularly I am going to cover your each lectures. Okay, so on or most of the course, most of the problem solving session will be lies on each Saturday from 4 to 6 p.m. Okay, so I'm requesting you to join here for get overall summary of that particular week, as well as also I will provide you some questions with a brief summary, okay, like brief background of that particular question and how to solve it effectively. So that will we are going to cover in all the problem solving sessions. So this aim of this session is not to get covered whole topic, okay. We are specifically aim to get summarize all the lecture content in 2 hours. That gets covered by uh, five lectures in each week, and then after half an hour or 45 minutes, we'll more focus towards the question and answer session. So before we begin, let me quickly introduce through this Bloom's taxonomy of educational objectives. So it is introduced by Benjamin Bloom. So it is not only related to the this course only. Anything you are learning, right? You need to follow this hierarchy like this. Okay. And how? What it is? Bloom's taxonomy. They said that there is a six steps of learning, or specifically six level of cognitive skills. Cognitive skills means learning something. It starts from high, low to high. So first we are, if we want to learn something, or we need to expertise in some subject, what we need to do, we need to remember certain definitions. Like for example, when we are child, what we are trying to do, we are learning numbers, we are learning abcds, okay, alphabets, some words. Then as we move up, like we went to first standard, second standard, 10th, 12th, we are understanding their meanings. We are also applying certain our numerical knowledge in our daily life. So after applying, we are trying to analyze something. So similarly, all these six steps are must required to learning anything. So in this case, what we are uh, targeting in this course, so we are targeting in this course like what is irrigation and drainage. So before that, we are expecting that you have sufficient background like of the agriculture, like what is soil, how soil works, okay. And in this, soil plus water is essential in irrigation and drainage, okay. Why? Because what we are doing, irrigation is required in either in either it is in rain-fed area, or either it is in uh, irrigated area, okay. So but we cannot irrigate randomly. We must have understanding of what are the requirement of plants, what are the maximum capacity of soil. If we'll not do that, that will end up to the wastage of our natural resources. So due to that, so first I hope that you have sufficient background in agricultural engineering, specifically irrigation and drainage. So I will also try to give brief overview in upcoming slides regarding what are the overview of soil and water resources. And then what we'll do, we'll try to understand specifically irrigation and drainage problems and understand their possible solutions. So there are multiple solutions. Then we'll apply that, we'll learn about what are the case studies that are already applied in this areas. We'll analyze that knowledge through learning that various techniques, and then we'll try to evaluate like what kind of evaluation technique we need to uh, we must consider. Like for example, like there are different kind of irrigation techniques are available. So how we can sure that uh, these are the perfect one, right? Whether it is a surface irrigation, subsurface irrigation, drip irrigation, sprinkler irrigation. So what makes drip irrigation more successful or more uh, conservative nature? For that, we must have certain evaluation criteria, and then after evaluating that there are still some flaws in even in drip and sprinkler irrigation system. So by analyzing, evaluating that systems, how we can create our new system. Okay. So these are the basic aim in this problem solving session, as well as this irrigation drainage engineering course. So before we begin, let me quickly summarize the week one content, what we have learned in this week. So it starts with we know that we are living on the world of salt. Why I'm saying like that? Because whatever water is available on the Earth's surface, out of that, 97.5% water is salt water. Okay, while only 0.076% of total water is fresh water. And out of that also, in fresh water, most of water are available in glaciers as well as permanent snow cover, so that cannot be usable by our like directly. However, this 0.3% of total water resources or freshwater available freshwater resources is available in lakes and river storage, and 30.8% available in groundwater. So that also we are extracting nowadays. Now, what is the problem? The problem is that that the population is increasing day by day, and by 2050 we have more than 2 billion people with us. So currently, right now we have a 7 billion people on the entire globe. Okay, and if we talk about India, so in India we have 120 or 130 crore. Okay, someone is saying 125 crore, 130 crore. So it is in between that. Okay, and out of that, this 7 billion, this is the current status, and by 2050 it mean in 2050 it means in next 25 years we have more than 2 billion people with us. So the 7 plus 2, we have total 9 billion people with us. Okay, but our all the natural resources, for example air, soil, water, all are constant. That's why it is very important to understand this scenario. Okay, like what amount of fresh water is exactly available, and in case of increasing in population, how this volume gets affected, because this is the constant volume. And if we are and as the population are increasing, what is happening? Per capita water availability of the entire world is get decreased. So if you can see this figure, so in 2000 and in 2020 or 2050, see the global water scarcity maps, and in this is the India, and so this is the Africa, and this is India. So most of African and uh, Asian nations, Southeast Asia, are will be under water scarce condition. Why? Because in India specifically, we hold 17% of the global population. Okay, so this 130 crore represents 17% of the world population, while we only have 4% of freshwater resources of the global freshwater resources, and 2% of the land. So with this constant resources, we need to feed the 17% people. Okay, and also these numbers will increasing in upcoming years. So under that status, so there is a many issues that lies. Okay, so if you can see this figure, that per capita land availability, that is also going to decrease for specifically for developing countries. Okay, because they are trying to using more their natural resources for economic purpose. And see this figure, like how declining it is for developing world and developed countries. So apart from that, this is a per capita water availability. So in that case also, per capita water availability is, this is shown on this x-axis, so it is continuously declining over the year. Okay, it will become around 1000 meter cube per year per person. Apart from this, what is happening due to increasing population and decreasing land availability per capita? What, because we have a limited resources, we need to feed more people. What we are doing? We are trying to do or we are injecting more chemicals in the agricultural field to grow more food within small land area. So ultimately that chemicals leaches out to the either groundwater or surface water and polluting our water bodies. Also, that is due to increasing in water consumption of the peoples of or the growing population, our natural water resources also get depleted. And there is also growing water intensive crop like rice, sugarcane. Okay, and we are also like increasing in the gross irrigated area to feed more people. Apart from this, we have also interstate dispute as well as inter national dispute in the water sector, specifically with the China, Pakistan, and in interstate we have a well-known dispute between Tamil Nadu and Kerala, Andhra Pradesh, Tamil Nadu. They are also having issues related to water distribution. So with these problems, so we need to feed 139 crore people by 2015, okay, with diminishing per capita land and water availability. So how we can do that? So there are two problems. Okay, so one is the supply side intervention we can carry out, and another one is demand side intervention. So what is meaning of supply side intervention? So supply side it means we can, so let me write down supply and demand. Okay, so supply side intervention we can do is how we can increase our water resources in our particular area. As water is a constant, and you know that most of whatever rainfall is falling, that is going to the as a runoff, and that will ultimately reach up at the ocean. Okay, through runoff. So, in what is happening due to that? So, as we are increasing, also changing in land use, land cover, like increasing in impervious area from urban land. So this runoff will happen quickly, and that will reach out ocean or any water bodies very quickly. It means water is not able to going moving down in our natural aquifers. So how we can improve that? Like storing our excess water, available excess water into the depleted aquifers. So there are various recharge techniques for that, that are available in the so that will also will cover during groundwater hydrology subject. So that may be around week 10 or week 12. But there are then another one challenge is demand side intervention. So what is that? So demand by, so we know that water is particularly required by either from agriculture, like from farmer. It means that are going to use in agriculture activity. Second one is industrial, right? Industries are also extracting lots of water to produce any byproducts, or also they are using for cooling their instruments. So there are lots of application of water. And like last one is humans, that so we are using water for drinking purpose. So that is also, so these three components are very important. So in demand side intervention, agriculture area, and how agriculture is using water by applying irrigation. So irrigation is basically we are applying to grow the food. And there are one important highlight about that is like most of or 80% of our water usage is from agriculture sector. Okay, 80% total water we are using in our day-to-day life. So most of the products that are we are taking up or using, that are from for like our feeding purpose, and that feed is generally produced from agriculture area, and that agriculture area is using 80% of the total water resource usage, while remaining percentage is divided into the urban usage like for drinking purpose as well as in industrial area. So due to that its importance, like 80% of the area or 80 percentage of total water resources are used by agriculture, and there are lots of flaws in our traditional irrigation system. Okay, because we are providing irrigation randomly without much knowing about soil status, plant status. So what we are trying to do is we'll try to first understand or learn about demand side intervention. So we know that plant required water, but it means we cannot apply randomly. We have certain techniques for that. We must consider that. Okay, for precise application of water, because our water resources available on the earth is constant, and that get not like so if we'll waste it in our agriculture sector, so it is the largest consumer of water, fresh water resources. So that will affect our other component also, and that will also like unpredictable, or like in future we have unpredict lots of uncertainty about water resource availability. So due to that, there are various demand side interventions. So in agriculture area, we can uh, like control the demand by knowing about more precision techniques that we need to follow. And in industry area, there are also lots of technique, and you know that in our home or there are lots of advertisement. Our politicians are saying that about how we can use like how we can save water during washing hand, washing utensils, washing our clothes. So all these are comes under demand side intervention. So but in this lecture specifically we will focus on the irrigation water demand management. Okay, and because it use 80% of the total freshwater resources on an average. Okay, that may vary on the region to region. So first question comes like what is irrigation, right? So irrigation is the artificial application of water to the soil to meet crop water requirements, and irrigation water is applied to supplement water available from precipitation and groundwater. And overall irrigation major concern is like how to apply irrigation, how to means what are the methods that we can select in specific region by considering soil type, slopes, then water availability, crop type, all that we need to consider, and then we need to choose certain techniques that are having the highest water use efficiency. Then how much to apply water? So for that again we need to know about soil type, what are the water requirement, daily water requirement of the plant, considering the various climatic factors as well as groundwater level. And then last question comes when to apply. Like right, we cannot apply daily. Like it is totally depending on the requirement, crop water requirement. Okay, if it requires daily, we need to apply it. If it requires weekly, we need to again apply it based on it, whatever amount it required. So, learning objective or learning outcome from this irrigation and drainage course is to understand the irrigation and drainage principles, like when irrigation is required and when drainage is required. So, as I said that if you know about hydrological cycle, so if the groundwater level is high, so due to the capillary frame, and water will come in the root zone. So all during all the situations that root zone will uh, come under the saturation, and in that saturated condition there is a no aeration. So plant cannot use plant cannot get oxygen, and in that case again there is a harmful effect on the plant if it is not water susceptible, excess water susceptible. So we'll understand that also, like in which case will require the drainage principles. Then design of gravity and pressurized irrigation system to understand the groundwater hydraulics, right? That is also important because whatever irrigation we are applying, that ultimately reaching to the groundwater through flow, infiltration as well as percolation. Then uh, there are surface and subsurface drainage system design, and finally we'll also talk about certain problems with the salt affected soils. So all this certain recent status about the our uh, irrigation productivity, so that already get covered. I'm not going into detail. You know that there are various benefits from irrigation, so that it strengthens the economy, it increase the employment opportunities, it is self-sufficient in flood production, food production, it raises the crop where nothing would grow otherwise, right? Because plant cannot survive without water, and if we have water and we'll apply it to the plant, so there is a ray, there will be raise of crop due to excess artificial water application. So grow a more profitable crop. So if you have a water, you can grow more profitable crops. It is also increasing in yield if we do precise irrigation techniques, and increasing in the aesthetic value of the landscape, like by growing gardening, horticulture crop, okay, by growing flowers in our landscape. So there is increasing in aesthetic values. And certain other benefits are indirect benefits, we can say that. So there are leaching of salts that is available on the crop root zone. So as I highlighted that if we are applying excess chemicals, and we are applying also right nowadays. So nowadays there is also one uh, program on organic farming that is going on, so that use the minimum chemicals, but in most of the, still there is in most of our farmers are using certain chemicals. So what is happening, that chemicals get accumulated over time in our soil, and whenever we are applying irrigation, so the salts are leaching down slowly with the irrigation water. Also reduce the wind erosion. How? Because we know that in erosion, it is basically detachment, transportation, and deposition of certain uh, soil. But if we are providing irrigation or irrigating any soil where the wind erosion uh, is dominant, so in that case, what is happening? So in that case, basically, there is a binding of that soil, and that reduce the, so it increase the power of soil and to fight against excessive kinetic energy of wind. Okay. Also allow us to do multiple cropping during a year. It provides jobs, definitely, right. It reduces the risks of crop failures and improve socioeconomic conditions. However, there are certain disadvantages of it. Just a second. Hi Abhinay. So, so there are certain disadvantages of it, right? Like if we are providing excess irrigation, that might impact crop yield, that will leach down the chemicals that we are applying for crops, that will not ultimately not available for the crop health. And there is also yield reduction due to the reduction in oxygen availability, basically due to the saturated condition. And there is again waterlogging and salinity problem. And now what are the problems, like why we are learning this course? I already highlighted that there are certain reasons that there is a problem in the demand side intervention, and our most of irrigation techniques available, or how we are conveying that water from any reservoir to the farm at farm scale, there are lots of losses happening in between. Okay, so due to that, there is a very less water use efficiency in various irrigation or canal structures. So due to that, it is very important to understand this subject and design proper diversion, proper distribution, diversion, and control structures for efficient irrigation, to design efficient irrigation techniques. And there are certain terminology that we'll already cover during week, so I'm not going into details. So when we'll solve the question, we'll cover it up, and then we'll first. So before learning about irrigation and drainage, as we are applying irrigation on the agricultural land, and land is basic or agricultural soil. Okay, so what is difference between land and soil? Anyone tell me? Hello, Rashida, Twara, hello. Okay. So land is basically soil is uppermost earth crust where we are growing the plants, and basically soil applies various minerals, required minerals for plant growth, as well as biological materials. While land is any physical features, or it consists of soil as well as any physical features like buildings, roads that lies on earth surface. So land is soil plus any builded structure on land, while soil is only that part of the land that supports the plant. Soil consists of, we know that, three phase: solid phase, liquid phase, and gaseous phase. So like solid phase consists of minerals, organic matter, various chemical compounds. Then in liquid phase we have a soil moisture or soil water, and in gaseous phase we have a soil air. Okay, and specifically this soil is consist of various layers. So topmost layer have a organic, if certain soil have it, and while this O layer certain soils didn't have it. Okay, so O, it consists of organic, uh, composed or primarily composed of organic matter. A is organic matter mixed with the inorganic product of weathering. B, fine material accumulated and enriched with calcium carbonate. And C, that represent the soil parent material. So this is soil parent material. B is fine accumulated material and enriched in calcium carbonate. It is CaCO3. And A is organic mix with inorganic products of weathering of parent rock material. Then we'll first understood about soil texture. So soil texture is basically relative proportion of sand, silt, and clay, and it is basically given by USDA textural classes. And in the analysis of textural soil texture analysis, we have a two method. One is a sieve method, and second is the sedimentation method. So sieve method is basically we are performing when the particle size is greater than 0.05 mm, and if particle size is less than 0.075 mm, we need to use sedimentation method. So in that we have again two methods: this pipette method and hydrometer method. So this is the textural classification of the soil, and I'm not going into detail. Okay. Then second properties comes is soil structure. Okay. Soil structure, we know that it is the relative arrangement of the soil particle in the soil, and it affects root penetration directly. It means again it's also impacting water intake and movement. So it It is very important to understand about soil structure. So you can see here various kind of soil structure, and in this uh, granular structure are more suitable for plant, while this blocky structure like this, okay, or platy structure, so that restrict the plant growth, okay, because you can see there is a no pores availability. These plates are lying in between that restrict the plant growth, while this granular structure have a pore space, so water, so it contain water as well as plant roots are also gets easily penetrated. Then we'll also learn about the bulk density and its measurement by gravimetric method, and particle density by uh, Gale specific gravity bottle and picnometer method. And there are certain properties that we have focused on, like porosity, so that is the volume of void available in the total volume of the soil. Then void ratio, that is the volume of voids to the volume of solids. So it's all are defined here, right? Porosity, void ratio, then specific gravity of soil, then soil water content on dry basis as well as wet basis, and finally we'll understand about how we can convert mass basis water content to the volumetric basis. Okay, because whatever we cannot measure, like if I provide you soil and that have a water, you cannot measure water amount directly that is present in the soil. What you need to do, you need to either evaporate this water, right, or you can do one thing more, that is you can add certain chemicals, certain uh, alcohol, like alcohol to evaporate water, and you can also measure indirect soil properties to estimate soil water. So that's why it is very important to understand this. And once we have a mass basis volumetric water, mass basis water content, by multiplying it with soil bulk density, we get volumetric water content. Okay. So after that, we have also talked about porosity, void ratio, as I already said, on this three-phase system like air, water, and solid. And then we'll started with the equivalent uh, depth of water, right? Because what how we are representing volumetric water content, we are representing in centimeter cube per centimeter cube, right? But how we know about what amount of depth, in depth amount, what is presented in the soil. So for that purpose, what we need to do, we need to convert it into the this equivalent depth. So if assume that there are 6 centimeter cube per centimeter cube of soil, like okay, 0.6 0.6 centimeter cube per centimeter cube of soil water is available. It means in 1 centimeter cube of volume of soil. So let's see, this is 1 centimeter cube soil volume. It means 1 centimeter depth, 1 centimeter width, and 1 centimeter length. Okay, now in this 1 centimeter cube of water, what amount of water is present? It is 0.6 centimeter cube. It means 0.6 centimeter cube. Let's say it is here. Okay, so this out of this 1 centimeter, then because you can see this also centimeter cube, it means 1 centimeter width, 1 centimeter length, and 1 centimeter and zero point 0.6 centimeter depth. So this zero point 0.6 centimeter depth of volume is available in terms of equivalent. So that's how we are converting it. And then we'll also talk about saturation field capacity, permanent wilting point, ultimate wilting point, and there are one of the important terms or certain phase system that we must understand for the soil water availability to the plant. So first one is the gravitational water. So whatever amount that are drained by gravity force, that is after like once you are ponding the water in soil surface, whatever water that are drained by gravity, that is known as gravitational water. And after this gravity drainage, there are certain waters that gets held by capillary force and surface tension, that is known as the capillary water. Okay, and after even this water gets drained out or evaporated, there are one more layer of the soil that's attached tightly with the soil particles, like this. Okay, that is known as hygroscopic water, and there are certain pressures that are uh, we need to consider. Like whenever there is a soil water availability to plant, so whenever pressure is in between 0 to 1/3 bar, that is known as gravitational water. So it means there is a water is draining by gravity still. Okay, in this pressure range, while in 1/3 to 31 bar or 1/3 to 31 bar, that is known as capillary water, and in that up to 1/3 to 15 bar, that is available to the plants. So in it, if soil water tension is in between this, so that water can easily extracted by plant. While if it is more than 15 and in between 15 or more than 15, you can just say, so that water is not available for plants. While hygroscopic water that are more tightly attached by absorptive force, okay, and that is present above 31 bar. Next to that, we have already talked about like field capacity. Again, field capacity is the maximum limit of maximum water available in the soil, while permanent wilting point, that is tells about lower limit of water availability to the plant. And whatever water is available in between field capacity and wilting point, that is known as plant available water. So after that, so we can see this photo that during wilting stage or whenever there is no enough moisture available in the soils, this plants gets looks like this. It means there is a no water availability. Then water holding capacity effect on of the soil texture. So there are two types of soil are shown here: coarse sand and silty clay loam. So let's assume that both have the same dry soil, while the gravitational water in case of coarse sand is higher, but gravitational water in case of silty clay loam is lower due to this coarse sand have a higher pore size, while this have a lesser pore size and small particles. Okay, the small particle have a higher capillary and surface tension forces. Due to that, that hold more water, so water holding capacity of clay loam soil is higher, while for coarse sand loam is lower. And unavailable water is also higher in silty clay loam, but coarse sand loam have a comparatively less unavailable water. Then we'll understood about the one of the important concept that is readily available water. It means the water that is available easily to the plant without uh, getting into the stress, and that also not reduce much yield at that point. So in this it is like lying here, okay, where water yield is reducing gradually, but here at this point water is yield is reducing drastically. It means it is a point where water is easily extracted by plant. Then we understood about soil water potential. So soil water potential consists of gravitational potential, metric potential, and osmotic potential. And then we have also focused on soil water measurement. So soil moisture is estimated either by direct method or indirect method. So direct methods we have methods like oven drying, alcohol burning, sand bath, hot oil drying, and physical appearance and field methods. So what we are doing, we are methods of measurement. We are taking the soil sample from the field. So if in definitely we are trying to measuring the soil moisture content of the soil. So what we'll do? So this is the soil and it have a moisture content. So in direct measurement method, we are trying to evaporate this water. Okay. So we have this wet soil. Then what we'll do? We'll put it in oven at 105 degrees centigrade for 24 hours. And what will happen due to that? All the water will get evaporated. Okay. This is a dry soil. Water gets evaporated. So by uh, subtracting this weight from dry weight, we'll get what amount of water that get evaporated, and then ultimately we are converting that into the mass based moisture content and volumetric water content. While in case of indirect measurements, we have techniques like tensiometer, gypsum box, radiological method, pressure plate apparatus, time and frequency domain refractometry instruments. Okay, so in that we are trying to measuring certain indirect measurement properties. So, for example, soil moisture tension, how tightly water is held in the soil, that gives by soil moisture tension. Okay, and other methods like plate and pressure membrane apparatus. We are applying pressure through pressure plate instrument that already we have discussed during our first week of this content. So I request you to watch it out. And there are advanced techniques like time domain refractometry and frequency domain refractometry. So in that case, we are using dielectric constant of water or dielectric constant of water, soil, and air. So dielectric constant for water is much higher than that of soil and air. So that leads to the accurate measurement of the soil moisture in any condition. So these are the very renowned technique, and that are also most of the sensors that are available, soil moisture sensors that use this TDR and FDR technique. Apart from that, there is also advanced techniques like remote sensing of soil moisture measurement, because whatever measurement techniques I discussed here, whether it is a direct or indirect measurement, so all these techniques are at point scale measurement, right? But we know that there is a lots of heterogeneity in the our natural land or any part of the earth surface. And if we are measuring even soil moisture at our home, and if you measure soil moisture content nearby or your neighbor field, okay, or in like apart 10-meter apart from your distance, so there is a lots of variability of the soil moisture condition. So due to that, this technique, we cannot use this technique for frequent measurement because it is not reliable, and also it is too costly to analyze and take too much of sample. That's why there is a Nowadays, scientists are focused on the remote sensing based measurement, in that they are using various techniques using infrared and microwave radiation to understand the behavior of topsoil. Okay, and then ultimately they are measuring the soil temperature as well as soil dielectric properties using infrared and microwave uh, radiation, and then they are converting these signals into the soil moisture. So with this, we have also discussed certain problems, and with this I am summarizing it here. And if you have any query till now, you can ask me from week one. We can discuss it. Hello, Vashika. Do you have any query? Hello, hello. Okay, I hoping that you are getting whatever I'm covering right now and you're following me. If you have any query in between, you can directly ask to me. So let's before we start our question and answer session, let's take a few-minute break here, and we'll again uh, rejoin here. Okay, let's resume our session. We are summarized till now. Summarized our one content, and now we'll focus on question and answer session. So first question is, at saturation capacity, the metric suction of soil is almost. So what is metric suction? So metric suction is the pressure difference between soil water pressure and atmospheric pressure. Okay. Due to capillary and adsorptive forces. It represents the tension with which water is held in the soil. Different moisture condition, we have a different pressure. Okay. So basically what it is, metric suction is the pressure difference between soil water pressure and atmospheric pressure. So why this differences lies in real situation, due to whatever soil water pressure held in this with the soil, that is primarily due to the capillary, that is uh, cohesive and adhesive nature of any material, and adsorptive forces. Okay, so that lies or that leads to the metric suction. And at saturation condition, we know that all the soil pores are filled with water. Okay, so they're asking at saturation capacity, metric suction in the soil is almost. So it is zero, right? Because we know that all the pores are completely filled with water, and there is no capillary tension making the metric suction zero. While at a field capacity, we know that that is next step to the saturation condition. So where all the freely available water that drains out, okay, and whatever water is holded by soil, that is primarily due by capillary forces, right? Right. So that uh, condition, we have pressure is in between minus one third to 0 to minus one third bar. Okay. While next to that we have a wilting point. So at a wilting point, uh, water, whatever water is available at field capacity, that also used by plant, or that maybe get evaporated or percolated, and ultimately the washed condition available or last stage of water available to the plant is known as permanent or alternate permanent wilting point. Okay, permanent wilting point, water is very tightly get attached with the soil, adsorptive force, and at that we have pressure is around minus 15 bar. So these are the figure that are representative of it. So at field capacity we have a pressure of 0. Minus one third bar or 0.33 bar. At building point we have pressure is around 15 bar. At hygroscopic coefficient or ultimate wilting point, you can also set that have a pressure is around 31 bar. But for this, correct answer is option D. Okay, 0 bar. Next question, relative proportion of sand, silt and clay, that is known as soil structure. No. Soil structure is arrangement of the soil particles, that is sand, silt and clay, into aggregates or clumps, and it affects aeration, root penetration, water movement, but does not describe relative proportion of sand, silt and clay. However, this is given by soil texture. And soil texture is basically, you can see this in figure, there are two kind of soil texture. So this is the relatively uh, clayey soil, okay, or maybe sandy loam, or maybe loam type of soil, while this is a sandy soil, okay. There is a huge difference in color as well as the textural properties. Texture, it means its size, okay. Size, you can see this relatively larger particles while this is have a smaller particles. Well, soil moisture, that related to the soil water available in the soil, and porosity is the volume of voids available in the total volume of soil. So correct answer is option B, soil texture, that define relative proportion of sand, silt and clay. Question number 3, among the predominant soil group in India, the largest, second largest area is under. So you know that most of the soils are first where like alluvial soil that comes the first, that have a highest representative in area in the India, as it covers most of the Indo-Gangetic plain and certain parts of the Gujarat, Rajasthan and Madhya Pradesh. And in second, it comes red soil. So red soil is generally available in the that is second largest available soil in the India, and that's predominantly found in southern parts, specifically Tamil Nadu, Karnataka, Andhra Pradesh, Odisha, and black soil. So that is available in Maharashtra as well as in Gujarat. So correct answer for this is option C, red soil. Right. So red soil is the second largest representative soil group in India. And its origin, like so red soil get origin or formed due to the weathering of metamorphic and indigenous rocks. It have a red color primarily due to the iron oxide and yellowish in lower version. And texture is sandy to loam. Question 4. Water movement in the topsoil profile and subsoil zone are respectively characterized as. So we know that water movement, so first entry of the water, whatever water is falling as a precipitation. In the, whenever it is falling through precipitation, it have a certain obstruction like various trees, various crops, and in barren land this rainfall is falling directly. In building also there is some interception. So whatever water is falling after interception loss, okay, that ultimately tries to reach down into the soil. So top entry of water into the soil is known as infiltration. while once water will move out beyond the root zone, that is known as percolation. So infiltrated water is also flowing as an interflow in between. So and there is also a base flow. Once the water will groundwater will move towards the river and that ultimately reach to the river. So correct answer is entry of water into the soil profile is infiltration, and second entry or water that is moving beyond the root zone, potential root zone, that is known as percolation. So option A is correct answer. While other options are irrelevant. So like seepage is lateral entry to water. Okay, and infiltration seepage is not correct answer because seepage refers to lateral and environment of water. Often comes from canal reservoir, not vertical percolation in subsoil zone. While this infiltration and percolation are vertical movement. Question 5. So this is the match kind of thing. So ideal fluid. So we know that ideal fluid that does not have viscosity. So and this match with this fluid kinematics. So fluid in motion without considering the effect of forces. Real fluid. So real fluids have a viscosity. Sorry. So ideal don't have viscosity. Real fluid have viscosity. Continuity equation. So we know that conservation of mass. So continuity equation represents the principle of mass of conservation in fluid flow, and fluid dynamics related to the fluid in motion without considering forces. Okay. So the correct answer is option C. Right. Question 6. The following again we need to match column A 1 to column B. So field capacity. So we know that at field capacity water available at the pressure of 0.12.33 bar. Poisson law. So Poisson law related to the pore size. Right. So it tells about flow rate through a tube of flow rate in a tube is the fourth power of the tube's radius, directly connecting to the pore size in soil physics. And Darcy's flow. So Darcy's flow is related to the laminar flow because laminar flow is basically that do not have more tortuous path, so it is flowing linearly, right? And it's have a Reynolds number less than one, specifically for groundwater flow. That is related to the uh, laminar flow. Permanent wilting point. So we know that at permanent wilting point pressure is of 15 bar, and hydraulic conductivity so that we can measure easily by using constant head permeability meter. Correct answer is option D. Question 7. So it is about calculation of porosity. So soil sample collected from field has a bulk density and particle density of 1.4 gram per cc and 2.67 gram per cc respectively. The porosity of soil sample in a decimal is we need to identify. So we know that porosity of the soil sample is given by 1 minus bulk density divided by particle density. So bulk density is given as 1.4 gram per cc. Particle density is 2.67 gram per cc. Let's put it here. So 1.4. If you solve this, you'll get 0.4757 as a fraction. It means there is a 47% porosity. If its bulk density of the particular soil having this and particle density of soil having 2.67 value. This is simple representation like so if you consider this bricks, brick, so that have a higher bulk density but low pore space, right? Right. This sponge kind of structure have lower bulk density but have a higher pore space. So lower bulk density means higher the pore space available. While higher bulk density it means low pore space available due to particles are attached very closely. Question number 8. So this is related to the Bernoulli principles. So I'm not discussing it here in detail. So we'll again solve this in next week. Question number 9. Which among the following not a cereal crop? So we know that rice is a staple cereal crop grown primarily in Asia and is a key food source for more than half of the world population. It belongs to the grass family, Poaceae, and is cultivated extensively in irrigated fields or rain-fed lowlands. Second option is wheat. So wheat is another major cereal grain widely consumed across globe and it's grown in temperate regions and forms the base for various food products like bread, pasta, and noodles. Like right, it is also belong to the Poaceae family. While gram, it is not a cereal but it is a pulse and legume. And it belongs to the Fabaceae family and which is rich in protein. So gram chickpea primarily used for protein rich food supplement. And last option maize. So maize is also known as a corn and it is again cereal crop. So gram it is not a cereal crop. So correct answer is option C. Which type of farming is practiced in higher population pressure on land? So as we discussed, there is a increasing in the uh, population, so there is a decreasing in the per capita water availability, but we need to feed the growing population. So what we are doing intensive subsistence farming. Okay, so that is option D. So in this you can see so there are extensive subsistence farming and intensive. What is the difference? This method uses a large area of land with minimal labor or inputs. Okay. While intensive subsistence farming, these practices use have a densely populated area and we have a limited land. So what they are doing, we have a more number of labor per capita available of land. It means all they are most of rely on agriculture and they are doing agriculture activity that is known as intensive subsistence farming. Question number 11. Which irrigation practice leads to maximum water conservation? So furrow irrigation, border irrigation, overhead sprinkler irrigation, or drip irrigation? So answer is option D, drip irrigation, right? Because drip irrigation are the most precise technique available nowadays. And then after drip irrigation, there is a sprinkler irrigation that's also efficient. Both are come under micro irrigation in the system. And uh, apart from maximizing water use efficiency, it also have a certain other benefits like it conserve water, it reduce disease, have a lower cost after certain periods. It also preserves soil from erosion and also like we can apply very precise application of chemicals. Correct answer is option B. Question number 12. From the following, identify which is not the micro irrigation emission device. So I told you micro irrigation have a sprinkler as a drip irrigation. So micro sprinkler are the part of irrigation system. Bubblers are also part of it. Drip perimeters part of drip irrigation system and hydrant. So hydrant is not part of irrigation device. So it is a pipe in a street from which water can be taken for stopping fire, cleaning street, etc. Okay, this kind of structure may have you observed in the field. So they are basically uh, used in the street to stop the fires, cleaning the street, etc. activity. So option D is correct. Question number 13. According to the ICR, that is Indian Council of Agricultural Research, total number of agroclimatic zones of India are. So we know that uh, according to the ICR, there are total 15 agroclimatic zones. So it is a land unit in terms of major climatic condition suitable for certain range of crops and cultivators. So the planning aims at scientific management of regional resources to meet food, fiber, and fodder demand without adversely affecting the status of natural resources and environment. And based on the climatic condition as well as suitability of crops and cultivators, there are total 15 agroclimatic zones that are given by ICR, are listed here. Okay, so you guys can tell me like from which agroclimatic region you are, what kind of crops are suitable in your region. Okay, so this will discuss in next lecture. Okay, I'll ask you about this. So please learn about it and we'll discuss. So, correct answer is option C. Question number 14. Which of the following is not a correct respect to drip irrigation? So don't worry, this will cover in upcoming weeks. So if you don't about this drip irrigation much, we'll discuss it in detail in upcoming weeks. It is general overview only. So drip irrigation basically very expensive investment. Okay, it have a higher uh, cost during initial stage, and it also laborious and time intensive. So post season there is a cleanup required of the entire system. It uses lots of plastic. So again this plastic leads towards the microplastic or plastic pollution of the water body, and it can also result in the seed germination problems if we are not putting it right place. And it requires the sediment free water because this micro irrigation techniques have a small drippers on it, and that small drippers uh, gets clogged if we have a higher sediment in this water. So correct answer is this. It save water wastage. Yes, it is correct. Fertilizer can be used with high efficiency, right? It requires very less installation cost. So this is wrong. So we need to identify which is not correct. So this one is not correct. It prevents erosion. Yes, but this sentence is incorrect. So option C is right answer. What is the full form of international organization FAO? So we know that FAO is Food and Agriculture Organization, right? So there are various sustainable development goals towards it. FAO is working also, right? Like no zero hunger, then life on land, climate actions, life below water. So they are also working with aquatic bodies. Okay. Next question, question 16. Average annual rainfall amount in India in mm is 800,000, 1200 or 1400. Correct answer is option C. Right. So to be precisely, currently average annual rainfall of India is 1190 mm. Okay. But this is not for like specific point. So entire region have a total average annual rainfall of 1190 mm. But if you see distribution, so most of the western region of India, right, like here, Gujarat, Rajasthan, they have a rainfall less than 500 as well as 500 to 1000. While as you go towards eastern side, so there is increasing in water availability or rainfall amount, and that is like in Meghalaya, there is a more rainfall is happening in this northeastern part. Correct answer is option C. From the following, identify the unit which is not correct for measurement of irrigation water. We know that irrigation water we can measure in liter as we are using certain bucket or tank to store our irrigation water volume. Liter per second is also we are using to identify like how quickly a field get irrigated or you can fill with certain storage structure. Hectare centimeter again it is unit of volume only because hectare means meter square. We can convert it in meter square. And centimeter again we can convert like 1,000 meter, 1 centimeter. So again meter into meter square that gets to meter. But meter square is not unit of irrigation. Question number 18. Identify from the following options which is the most important component of determining crop water requirement. Crop water requirement, like so which component? Free-flowing irrigation, evapotranspiration, leaching water requirement, and deep percolation of water. So you know that evapotranspiration is the most essential component for irrigation because most of water are getting utilized by uh, plant as a evapotranspiration for the process of photosynthesis, and this evapotranspiration requirement are varies during entire crop growing season. So during initial stage, so water requirement is a comparatively less. As crop gets developed and there is a starts of flowering, grain setting, and ripening, water requirement will increasing, and then there are less water requirement during late season stage, like ripening and harvesting stage. But mid-season crop development stage, like during flowering, grain setting, we require more water. Option B is correct. And again, this is the how crop coefficient is varying. Okay, during entire season. So crop coefficients have a base value during initial stage, and it have a highest rate of change during crop development stage, and have a highest value during mid-season stage, and it declining drastically at late stage. All this will come in upcoming lectures. So this is just overview. Question number 19. Question number 19. In the following match each of the entries in column 1 with the most appropriate entry in column 2. So deep tube well it related to the aquifer, right? The aquifer is any geological material that contain that yield water as well as transport water and store water. And reservoir, so reservoir is related to the whatever amount of water we are transferring reservoir to the canal. So reservoir is more related to the canals. Arid climate, so we know that arid climate are in the Rajasthan, while humid and perhumid ecosystem in West Bengal and Assam. And conjunctive use of water it related to the surface water and groundwater. It means we need to use our resources consecutively, like during dry season maybe we can plan to use groundwater, but while in wet season there is lots of water available on the surface or rivers, small water bodies. So we can use that consecutively. We need to plan it better. Okay. For efficient water or sustainable water resource management. Correct answer is option C. Question number 20. In the following, match the entries in the column 1 with the most appropriate link entry in the column 2. So core cylinder, so we know that why we are using this core cylinder. So it looks like this. We have core in this lead also. So that core cylinder we are using for taking soil sample. While infiltrometer, so the infiltration just tells about water movement in the soil. So it is related to water movement. While tensiometer, we are measuring soil moisture tension. So soil moisture tension generally tells about how tightly water is hold on the soil surface. So it is related, and by measuring soil moisture tension, what we are doing, we are converting that value into the soil water content or soil moisture. While vapor pressure that are related to the hygrometer or hygrometer we are also using it to measure relative humidity. So relative humidity is more or less related to the vapor pressure. Okay. And rain gauge we are using to measure rainfall. Correct answer is option B. Question number 21. There are various instrument is given in column 1 and we need to match like what or what entity it is measuring. So anemometer, we know that anemometer we are using to measure wind velocity. What velocity? It's just given the wind, measuring wind velocity. Barometer, so barometer we are using to measure pressure. Then hygrometer, hygrometer we are using to measure humidity, right? Like measuring the vapor pressure, or you can say humidity. Then celiometer, so it is used to determining height of cloud base, which relates to cloud covering. So cloud covering, we are using celiometer and thermometer for temperature. So correct answer is option B. Question number 22. What does the term field capacity refers to? The soil water constants. So we know that field capacity is amount of water that is present in soil after gravity drainage, and it is the upper limit of the plant available water, right? And when during designing irrigation, we are using water content field capacity, water content permeability point to represent higher and lower water availability. So it represents maximum water content that soil can hold against gravity. It is correct. Okay, so option A is correct. What are the other options? Minimum water content? No, it is not correct. So this minimum water content known as permanent wilting point. Volume of water a soil can absorb in a 24 hours. Not correct. And water content at which soil is saturated. So that is known as saturated water content. Question number 23. So what does the term permanent wilting point refers in the soil water constant? So as I already defined, so water content where plants begins to wilt. This is correct. Water content where plants recover. The minimum water content at which plants can no longer recover from wilting. And maximum water content just before. So correct answer is option C. Right. So it is the minimum water content at which plants can no longer recover from wilting. It is more accurate as compared to this. So correct answer is option C. question: how does the hydraulic conductivity of soil affect suitability of for irrigation? So higher hydraulic conductivity means less water retention. Exactly, it means it allows more like fast movement of uh, water in the soil and leading to poor irrigation efficiency. It is correct. Okay. Lower hydraulic conductivity means higher water retention, ideal for irrigation. Okay, is also correct. Hydraulic conductivity does not affect irrigation suitability. This is incorrect, totally incorrect. Higher hydraulic conductivity allows rapid water movement, making ideal for certain type of irrigation. This is also incorrect. So hydraulic conductivity reflects the ease with which water can move in the pore space. Higher hydraulic conductivity can advantageous for ensuring sufficient water reaches to the plant roots system quickly. Okay, so option D is correct. Okay, with this, I'm ending this session here. So again, I request you to watch out or scan this QR code for watching this problem solving session. And just a second. Okay, so with this, I'm ending this session here, and I'm requesting you to watch out this YouTube channel for upcoming sessions, or also you can subscribe this channel, and whatever content I covered, I'm uploading it in this Google Drive folder, so you can click it here and you can easily access it. So in this lecture, in summary, we have covered about the basic properties of soils, and basically we are specifically focused on interrelation between soil, water, and plant relationship, and we have solved certain questions. So with this, I'm ending this session here, and if you have any query, again, I'm requesting you to write down to my provided email ID, and also you can join our next session for more update. Okay, so thank you so much for joining.